In this video, we're going to be doing some Pythagorean Theorem practice. I have 6 questions chosen for this video. Question 1. If two legs of a right triangle are 9 and 11, the hypotenuse is... For this question, this is technically saying that what if we have the sides, right? So for a right triangle right here, a right triangle has a right angle which is technically 90 degrees, and it gave us the sides. Well, one thing to tackle this problem down is to know the sides. If we know two of the sides, we could use the Pythagorean Theorem to find the hypotenuse or one of the sides. Since they gave us 9 and 11, 9 is going to be our smaller side and 11 is going to be our longest side because 9 is less than 11. Now the only thing we're missing is what is the hypotenuse. So this is a question mark, or you can just put an X. So by using the Pythagorean Theorem, which is a squared plus b squared equals c squared, we already have two of our legs, which is a and b, but we don't know what our hypotenuse is, so we have to solve for c squared. So we're just going to substitute our legs in the values of the legs. So 9 squared plus 11 squared equals c squared. This is going to be 81 plus 121 equals c squared. You can do this faster, you put in a calculator, but I recommend just going through the steps so you don't get lost and get the incorrect answer. 81 plus 121 is going to give us 202 equals c squared. By taking the square root of both sides, so we get rid of our square, that cancels out. We're just left with c equals root 202. The reason why we leave it root 202 because we cannot simplify it any further. So our only answer choices here is going to be D. Question 2. Question 2 is basically the same thing as question 1, but the numbers change. What is the length of a hypotenuse of a right triangle with legs of lengths 7 and 8? The best way to do this is, again, draw a picture, which is a right triangle. We have the lengths of our legs, which is 7 and 8. Remember, this is our shorter side, which is 7, and our longer side is going to be 8. We're just missing the hypotenuse. So by using the Pythagorean Theorem, a squared plus b squared equals c squared, we just basically substitute everything in for a and b except c. And basically do the same thing by squaring our numbers. Then add 49 plus 81, which is going to give us 113. Take the square root of both sides. Our answer is going to be c equals root 113. This is going to be D as answer. If you're wondering why root 113 is going to be longer, well, put this in a calculator. If you put this in the calculator, root 113 is going to give us 10.63. So you may wonder, the hypotenuse is always a longer side. Well, is 10.63 longer than 8 and 7? Yes. So root 113 does make sense. Some people might think that, oh, it might be a really small number, but really by putting an answer into a calculator, you can check to see that is my answer correct. By looking at root 15 here, root 15 is going to be smaller, 3.87. And that's going to be smaller. So if you get root 15, double check answer by putting this in the calculator. It's going to be smaller than our legs, the lengths of our legs, 8 and 7. So that is not going to be our answer. So it cannot be 9 or 15 because if you do our work, you do not see that. Why would we select that? So the only answer choice that we have is going to be D. Question 3. This question is a free response, meaning that it has no multiple choice answers. So you might these probably get a little bit harder or difficult because there are no multiple choice answers to see if you get it right. But I'm gonna help you guys with this one. In the accompanying diagram, I'm not sure why they use that, but it's fine. Of a right triangle ABC, measure angle C equals 90, measure angle A equals 45, and measure angle C equals 1. The only thing I like about this problem is that they label it for you on the diagram, so you don't have to do it. So less work if this is time. Find in the radical form. Remember, this is really important. If your answer is not a radical form, meaning it has a square root, then your answer is wrong. We want to know the length of AB. We don't know what that is. Well, one thing you must know is your special right triangles. You remember for a special right triangle, a 45, 45, 90. Right here, right triangle, our hypotenuse is gonna have an x root 2. It's gonna be some number times root 2. And the legs are our triangle, right? Triangle is gonna be the same. So x and x. You can see it might be written as something like this: 1, 1, and root 2, like that. If you remember your special right triangle, then you're on track. Our hypotenuse for this answer is gonna be root 2. So the length of AB is gonna be root 2, because our hypotenuse for this special right triangle for the 5, 4, 5, 90 is gonna be root 2. It's not gonna be x root 2 because this number here, this x value is just a missing number. So basically it's just a 1 here, 1 root 2, but you only need to write 1 root 2. So just remember that it's just root 2. And they were asking us to find the length of BC. Then our length of BC is going to be the same one as 1, okay? But this is much different. It was a 30, 60, and 90 right triangle. So our answer for this question is going to be root 2. And it is in radical form, so that checks our answer off. In the diagram shown of right triangle BAC, measure angle A equals 90, measure angle B equals 45, and measure angle C equals 8. This question is the same thing as 3, but except the only difference is that it is multiple choice instead of a free response question. I technically find the free response question a little bit more harder than the multiple choice. So by remembering our right triangle, we know that the length of AB here is going to be 8 also, and our hypotenuse is going to be root 2. But what is the length of BC? Well, you remember that this has to be some value of x. If these were 1 and 1, this would be just root 2. But since the sides of our right triangle is 8, this means that this right here, this x is going to be x equals 8, so 8 times root 2. So this is going to be 8 root 2 for the length of BC. So our answer is going to be B for number 4. In the diagram below, triangle RST is a 3, 4, 5 right triangle. The altitude h to hypotenuse has been drawn. Determine the length of h. If you remember your 3, 4, 5 right triangle, this is also another form of special right triangle, but this question number 5, I chose it because it's a little bit more harder than the rest of the question. Questions 1, 2, 3, 4, and 6, which is going to be the next one I'm going to show you, are a little bit more easier than question 5. For this one, you might be wondering, how do I approach this from? Well, 3 is going to be a shorter length, 4 is going to be a longer length, and 5 is our hypotenuse. So we're looking at this hypotenuse here, and they gave us some variable right here, A and B, but we want to find the height of h. So we're just going to set up our question like this. This is 5 here, so 5 times A equals 4 squared, okay, equals this right here, equals the longer leg right here. By doing that, we just square 16 and divide by 5. We're gonna get A equals 3.2. Let's do the same for the side where B is. Now it's gonna be 5 times B equals 3 right here. 5 times B equals 3 squared, and B equals 1.8. So if you're confused, remember that the Pythagorean Theorem, B squared equals C squared. These two add up, and this is going to be root 25, which gives us our hypotenuse, right? That's going to be a little bit longer for me to show, but I'll make a separate video to show you how the 3, 4, 5 triangle plays a major role. By having our answers for A and B, find the length of h. H squared equals 3.2 times 1.8. You can see this is the Pythagorean Theorem. I can see that we're trying to find the height of h, so we're squaring that also, and we already squared these and divided by 5. So by multiplying that and taking the square root, we're gonna get an answer of 2.4, and that is our height of our altitude for this question. Question 6. In the accompanying diagram of triangle ABC, a right angle is at C, which is right here, this square right here, this little square. AB, the length of AB equals A, AC equals 4. Find BC. We don't know what this is. Well, let's use our Pythagorean theorem. A squared plus B squared equals C squared. We already know our shorter leg, which is A So for square, we don't know our longer leg, so we're just gonna leave it as b squared. And we already know our hypotenuse, so a squared. Now let's break this down step by step so we don't get a wrong answer. 4 squared is 16 plus b squared equals 64. Subtract 16 to both sides. We're gonna get b squared equals 48. Square both sides. We get b equals root 48. By remember how to get your radical in simplest radical form, just divide 48 by perfect square numbers. A divided by 16, which is 4 squared, we're gonna get this. So I'm just gonna write this on this side. Root 48 equals root 16 times root 3. 16 is a perfect square of 4 squares, so it evenly divides into 48. So root 16 is going to be 4 times root 3. We cannot simplify root 3 anymore, so we just leave it. So our answer for the length of this is going to be b as our answer.